Hello, everyone. Welcome to Global Hack Week. It looks like I need to remove the Global Hack Week logo off the middle of my screen, but I'm super excited to be back here for the last part of our game world building series with recurrent neural networks. This is part 3. It's the final part. I'm glad to see y'all here in the chat. Before we get started, I'd like to remind y'all to check in and register your attendance. I sent a link in the chat. But if you haven't registered already, make sure you do. It's events.mlh.io/events/11165. That'll allow you to register your attendance at this workshop to make yourself eligible for any swag we'll be giving away for this Global Hack Week. I'm super excited to be here with y'all, finishing up this stream series. So we're going to just kind of dive straight into the code this time. The last 2 sessions, I gave a little bit of an overview of recurrent neural networks, as well as gated recurrent units and long short-term memory. We started to integrate these into our code the last 2 times, but now we're just going to kind of dive into debugging our model, as well as integrating a few other key pieces that are pretty interesting. Before I do get started, I'm going to share a bit.ly link to the code from earlier. So I committed some code in Jupyter notebooks from both part 1 and part 2 with our models, and I have a little to-do list there as well as far as what we'll be doing for this stream today. So let me get that bit.ly link real quick, and I'll put it in the chat. All right, so it's bit.ly/rnn code repo, and I'll put that in the chat as well. Hello to Sam. I'm glad you're here. All right, so for anyone who wasn't able to access the code in part 1 or 2, or maybe it's your first time tuning in, you're able to access the code right there. And I will just kind of dive straight into what we did last time and start debugging our model so we can get those pesky error messages away and start doing the fun things, which is generating our characters. All right, so in part 3, I copied over everything from part 2 into part 3, IPython or Jupyter Notebook file. And I'll kind of walk you all through what we did the last 2 sessions. So you are a little bit more up to speed as far as what we've done in the past and what we'll be doing for this particular session. So we have part 1 and 2, as well as our to-do list. So in part 1 and 2, we imported all these statements. So you can see some data managing libraries, as well as TensorFlow, which is a machine learning library in Python, as well as some specific functions and libraries from the TensorFlow library to allow for a little bit easier machine learning model building. So we imported those. I'm going to run this in our part 3 file, just so we have everything kind of up to date. All right, so that is running. Looks like we're good to go. Here, we was brainstorming how we could get our memory to be a little bit more efficient for our data. And the second part, we integrated the national name CSV file, which has a lot of baby names from the US, all the way from 1880 to 2014. Has every single baby name that is, I think, from 5 instances up to thousands, has the year, the gender, the name, and the count along with the year. So we are just focusing on names from 1880, but the overall data set has 1.8 names. There will, of course, be repeats from 1880 to 2014, but we integrated that into our name generation model. So here, we're reading in that data set, we're making sure it's all there, we're dropping some irrelevant columns and integrating that into our name generation model. So I'm going to run this again in our part 3 file. Looks like we're running in no errors, it's printing out everything. Here we can see a combination of our work from last time in part 1 and 2. So we can see some of the work we did in part 1, where we just used a basic list to generate our character names. We made this into a vocabulary, and we're able to actually craft that model using the sequences in each name. You can see a lot of kind of like specification. If you're curious about more of the specifics of this, you can head back to the recordings from part 1 and 2, but just essentially know this is the model that we built to define our character names. So I'm going to run that. It looks like all those epochs are starting to run. All right. And also, if anyone has questions, feel free to drop them in the chat. I'll be going back and forth between the code as well as the chat to make sure that I can answer anyone's questions throughout this process of debugging, as well as adding on some functionality to our code. All right. Looks like the model's training well. So here's where we're actually calling our model. This is where we're actually generating our character names. The seed is what essentially the character name will start with. It's just a single C character for this one, but we can add in any letters. We can even do something like CH, and that will change letters. We've done CH a few times for the past 2 parts. So I'm going to change it to, let's just do MI and see what it comes up with. This is mapping all of our characters to indexes, and we're actually calling a function here based on the probabilities that our model is giving us, and it'll spit it back out. So I'm going to run this, and it looks like the name we have here is Minnie. We have Mila, Minda, Mina, Mina again, Minnie, Mina, Maite, Milda. So we can see that it's generating a bunch of names that start with MI. So now we're going to go on to what we did in part 2 after we integrated that national names data set. We started to work on our age generation and physical characteristics generation. So we imported some new libraries and functions from the TensorFlow library right here. So I'm just going to re-import those. And then here's where we started building out our model for age and hair color generation. That's the first physical characteristic that we focused on. We may have time to focus on a few additional ones in this particular session of the stream, but we will probably focus on image generation before building out the physical characteristics anymore, just so I can show you a little bit more about like how you could use this in day-to-day for generating aspects of your game. So this needs to be debugged. The model is generating properly here, like we're not getting any errors, we're getting a proper function, like everything is being returned. But here, when we're trying to actually call the model versus just create it and deploy the model, we're running into some issues. So that's what we're going to begin debugging today. In addition, what we have on the rest of our to-do list is debugging this generator model, as well as inputting this information into the OpenAI API in order to generate an image of our character. All right, so let's run this final cell and see what's going on. Here, okay, we have random is not defined. What line this is coming from, sample hair colors. All right. I think this might be able to be fixed with just an np dot random. Let's see what the next error it gives us. All right, this one's longer. Invalid data type of string. And which line is that coming to us from? Predicted probabilities. All right. Line 17. It's this long one. Let's see. So we have, we're accessing simple ages, the NumPy array, as well as simple hair colors at index 0. Let me look at this a little bit more closely. All right, so predicted probability equals model.predict. We have our sample ages, we have our seed index, and we have our sample appearances, or sample hair colors. All right, I'm not quite sure what's going on with this, so I'm going to ask Copilot if it has any idea what to do with this particular error. So I'm going to copy this up here and see if we get any answers before I head to Stack Overflow to try and debug this. All right, invalid data type of string 160. I can convert the data type of name column in the national data frame set using the asType method. All right. I'm curious though where we're utilizing national data set. Because I don't want it to change all these 14 lines. I'm going to discard and look at, I think it is potentially the seed index. So let me look at what that says one more time so I can address it a little bit earlier above. So it's Control I. Okay, asType method for, okay. So it needs to, it's probably because we're using a data frame versus a list. So I'll just do this up above when we're processing this. So we're going to go all the way up here back to our processing. And we're going to set national data set. I'm not quite sure. Let's see. We're going to edit column name, and we're going to put it as type string. Let's see. Let's see what this does. And then I'm going to print off national data set at the name column. I don't want to do index just 2. I don't know, it's kind of random, but then I will print off the type so I can see the type, and I'll do that both before and after this so we can see how it changes the data type of this particular item. All right, so we're getting class string both times, which is interesting. I'm going to maybe alter, let's do national data set at index name. Oh no, I hit shift again. At index name, I'm going to close this off, set it equal to that. Let's see what this does now. All right, I'm going to try running this instance of the model one more time and see if we're getting the same error. Invalid data type again. All right, so let's see where we need to fix this. Because it's for the seed index. Of just names. Oh, okay. So maybe I need to as type string right here and see what happens. No, okay. Okay, let's, okay, no. We're going to Control Z. I'm going to go back down to the level of right here. Let's see if we can do this. Interesting. All right. I'll run this again. Let's get back to the original error. Invalid D type of string 96 for this. Let's see what it says for the entirety of the thing. All right, so what is this doing? Convert the name column using as type, but it's changing sample ages. It's a little odd. Let's accept it and see what it does. Anything? No. Okay. String 192. Okay, so we're getting a different string type. Because the size is the number of samples rather than the number of integers. So, okay, not scriptable. I'm gonna go back to the okay. That was the number of samples, and then originally, okay. Let's run it again. All right, so I think it's time to go to Stack Overflow. I think GitHub Copilot doesn't have quite the right solution for this one. Looks like we have a question. What model are we building? So earlier we built a model that generated character names for video games. Right now we're building on a model that will generate both an age and a hair color for them, with, I guess, like the caveat that it will pretty much only generate these hair colors or an age between 18 and 30 for those two, but we're working on debugging kind of the us instantiating this model real quick. And then we are generating some random numbers here. We're not quite generating our random hair colors quite yet. All right. So invalid string type. All right. Oh, okay. That might work. So what I'm reading on Stack Overflow is that when you're trying to convert it to an integer, it doesn't necessarily read that the top like header row is an integer. So it's because it's, let me move back over here, and national names. So we're trying to change like this particular, oh, that wouldn't apply here. It wouldn't. Okay, never mind. I'm thinking out loud. Let's see what we need to fix. All right, so invalid string type. It's coming from line 17. For our seed index and our sample hair colors. Let's see one more time what it comes up with. All right, this is not gonna change. Okay, let's just first see print national data set name 0, just to make sure that like we're accurate and that it is a string. Okay. Yes, so we're getting a string. Let me try just doing this right here. As type string string 0. Okay. I'm going to pull out the seed index and see if that makes a difference, because we're already predicting character names up above. So I think I'm just going to change it so it's solely our sample hair colors and our sample ages, and see if that will change anything in the errors we're getting, just because we already have that model that's working up above. All right, we're still getting this error. So it is coming from sample hair colors, I think. So let's maybe pull this out. And let's see. All right. Too many parentheses, I fear. Parentheses was not closed. There we go. Okay. Run this again. Closing. Okay. We have I think it's but that's being closed properly. That's weird. Okay. All right. So bracket is being closed. But unless I need to be doing this. That should fix it. Does not match opening. Okay. I don't know what's going on. It looks like we have, let's see, let me space it out so I can. Okay, so the first two are being closed. This is being closed. Oh, we need another. There we go. Okay. There was just too many of them. All right. Built-in function or method is not scriptable. For this. Okay, let's see what's going on with this. All right. So the error message, type error, built-in function or method, it's not scriptable. Typically raised when you try to use indexing with a function or method. It's not allowed in Python. Seems to be I'm trying to use indexing on NumPy array, which is a function that uses used to create arrays. Okay. That would make sense. Create an error. Okay. Sample ages. Okay, so I do have this and then predictive problems. Because that is that not the code I had exactly before? I'm kind of confused. Create a NumPy array from the element index, then passes the array into the NIST and model production method. Okay. Let's just copy this over here and see what difference is, if there's anything. Okay, this is the same. And almost positive it's the same. Yeah, it's the same. I'm going to comment this out and see. I feel like GitHub Copilot is just wrong. Tuple index left out of range for predictive probability. Okay, so I think we maybe need to bring back a little bit more of the code that I deleted when we were trying to debug, and we can get back just to predicting the sample ages. All right, so we'll have to do it at index 0. All right, tuple index also out of range. Okay. Let's see. Explain. Let's see what's going on. All right, so honestly, yeah, let's print out predicted probability and see what's happening. Okay, it looks like the issue is with the first one then. Okay, the input I'm modeling to model predict is not correct. The most recent one, leave the input age, and that's it. Okay, which would be sample ages. Okay. Still not working. Okay. exception encountered when calling functional, call arguments received by functional, TensorFlow. What does this mean? Okay, so the exception they're finding okay. Output is equal to output, which is going to be this. All right. What does this mean? Explain. Okay, the error message you're seeing is a key error raised when calling the model predict method. This error typically occurs when you're trying to access a dictionary with a key that doesn't exist in the dictionary. Let's look at code snippet. Looks like you're passing a list containing a NumPy array of sample ages to model predict. The model predict method, okay, where input corresponds to a feature expected by the model. Okay. This might be it. We might just not be reshaping our input properly, which I think makes sense with like how we're building our other models. So I'm going to try that. I'm going to do that with reshape 1, -1, and let's see what we come up with. All right. List has no attribute of reshape. Well, we can just reshape it manually like we did up above. So yeah. All right. We can do it with because of we have our embedding age. Maybe that is what we need to be calling. Oh, I see. Okay. I think I need to be reshaping the input layer before we embed our age. So let's do reshape input, do reshaped age is equal to input, or honestly, just try this and see if that works. Value error. -2. Okay, never mind. We'll be reshaping it here. Input age at 1, -1. Reshape 1, -1. Another parentheses here. And then we'll do this with the input age. Tuple object is not callable. Okay, we're going to try this down here and see what happens. All right. Have our sample ages. Reshape 1, -1 with our sample ages. And then delete all this, close up our parentheses. All right. Takes 2 positional arguments, but 3 were given. All right, we go up here, make sure we're doing it correctly. No, we need one more parentheses. This needs to be nested a little bit further. All right, parenthesis, delete this one. Let's see what happens. Interesting. Array, missing required. Oh, because I forgot to put this in. All right. I'm getting another exception error. Fun. All right. I think I'm going to switch over from this debugging, as we've spent a little under 40 minutes debugging together. We're not making a ton of progress so far with GitHub Copilot and Stack Overflow. So even though we're not calling the model for our age, we are generating a few random integers. We did build the model. So I'm going to move into using the OpenAI API to start using the DALL-E library in order to generate images of our characters, which you can use to kind of in tandem with the randomly generated numbers for ages and our randomly generated name. We can make a character picture to go along with that as well. And I think it'll be a little bit more enjoyable than just debugging for another hour or so. All right, so I'm going to make a new code block, and for this particular part, we're just going to be taking in one of these random numbers. We'll have it randomly generate us one of them. We'll take a randomly generated name, and then we can also randomly generate a hair color as well. We just won't be using the model, as the model is still kind of in the debugging process to generate a picture using DALL-E. If you're unfamiliar, DALL-E is the image generation part library of the OpenAI API. I will change my screen to be sharing the documentation for that, and we can kind of talk through that. So DALL-E provides a way to generate images and manipulate images. So you can create them from scratch, which is what we'll be doing. We might go into making edited versions of the image by having the model replace some areas of an existing image, based on a text prompt. We'll be using the API, the OpenAI API. They have some starter code here, and we'll work with the prompting it a little bit. If you don't already have an OpenAI key, you can just kind of follow along with what I'm doing, and I'll show you what the images are generated. But if you have your own API key, you can run this code on your own. I do believe they have a kind of a student starter. Oh, I just realized I wasn't sharing my screen of the OpenAI documentation. They do have a free starter trial, so you're able to get some credits, I believe, for OpenAI. But if not, you're able to fund it. I think the minimum is $5 or something, and you get some credit, which I've never even come close to using all of that. So this is what we're going to get started with. I'll walk you through the image generation, but I'm going to go away from the screens just for a little bit so I can put in my actual API key. And we'll be using the names we generated as well as one of the ages to come up with our character generation. All right, so I'm going to go back to my code screen. All right, so I'm going to go past this error right here, and we're going to move on to OpenAI API image generation of characters utilizing the DALL-E library. So the first order of business for using OpenAI and their APIs would be to actually import the library. So the first thing we're going to write is from OpenAI import OpenAI. It's pretty simple. We're going to run that. No module named OpenAI, which means I need to install it because I'm on code spaces. So I'm going to type in pip install OpenAI. All right, so it's going through and downloading all that. All right, it looks like this has been installed, and run this again. Perfect. All right, so after that, we're going to go through and write the rest of the code for our image generation. So the next thing we're going to do is actually call a client. This is where we're kind of like instantiating a class of OpenAI. So we'll have client be equal to OpenAI. And then we're going to integrate our API key here. So right inside of the OpenAI brackets, you're going to have API key underscore, and then it's going to be set equal to your API key. Whenever it comes time to generate the images, I'll put in my actual API key off screen, and then I will show you the images that it generates. So the next thing we need to do after that is pretty simple. So we're just going to create a response instance and actually generate that URL. So we're going to have response, and we're going to set that equal to client images.generate. And within that, we're going to be specifying a few things so the API is able to call it properly. So I hit shift, oops. We're going to set the model to be equal to Dolly. Let me get all the brackets right. I'm going to copy in the model right really quickly here. We have Dolly, and then the next thing we need to do is have our prompt. I'm going to leave this blank for a second, just and we can come back and fill this in a second. After we have the prompt, we need a size. I'm just going to use like a standard pixel square size. So I'm going to have it be equal to a 1024 by 1024 pixel image. This is going to be a perfect square, and it'll be relatively large, but we can resize that as necessary and make it into a rectangle if we want later too. As far as quality, I'm just going to do standard. We can tinker with this later as well if we want a little bit higher or lower quality images that will take less time or more time to generate. So we'll do standard. And the last piece of information we need is the number. So this will just be equal to 1. And then after that, what we need to do is we need to have a way to essentially access our information. So we need to find the information, which will be on OpenAI's server. So we will have this be image URL, and we're going to set this equal to response.data. And then we're going to go to the first index, or the first item in there at index 0. And we're going to access the URL. And I'm going to print off our URL. So we're able to actually click on that and view our image. So briefly, I'm going to take this off screen, and then we can go back to the screen so we're able to access this image. But I do want to change the prompt. I think I'm going to do it to something pretty simple. Team at a hackathon. So you're able to like just first see like how the image generation technology works. And then we can input our characters' names, their ages, as well as some physical attributes about them. So I will move my screen back over to the Open AI API, and then I will show you what we end up generating in just a few after I put in my own API key. All right, putting in my API key, and I'm hitting run. Well, it looks like I ran into an error. That's telling me I have an invalid API key. That's interesting. So I'm going to go into my account and delete and generate a new one. So Global Hack Week RNN3. I'm going to create my secret key. I'm going to copy that directly into the code file. If it will let me copy. Interesting. Okay, it's not. Oh, okay, I see. All right, I think that seems to have fixed the error. It's thinking right now. All right. And it looks like we have our first image. I'm going to switch my screen over to this first image we generated with the OpenAI API. So this is the first image we generated. As a reminder, the prompt we used was a team at a hackathon. I think it did a pretty good job of generating a high quality image pretty quickly. So now we're going to use it to generate images of our characters. So let's go back to our code really quickly. And we can get started generating some images of those characters. All right. All right, let's switch back over to our code. All right, so as you can see, I changed my API key back to your API key, but at the bottom it outputs a URL, which is what we click on to just view our DALL-E generated image. So in here, I'm going to go up to our name generating model, and I'm going to have it generate. Okay, so Milda is our AI generated name. We're going to have our prompt be a picture of a video game character named Milda, who is, let's see, 22 is the first number I saw, 22 years old, and has, let's see, first one I saw was red, so has red hair. So I'm going to have it generate 3 different images, and then I'll get back to you after I run this really quick. All right. Okay, I just did an overlay completely instead of just my face. All right. I'm going to remove this very quickly, change my screen again, and I can put my API key in, and we'll be generating that image of Milda. All right, it's only letting me generate 1 image for this. So I'm going to change n back to n equals 1 versus n equals 3. It's thinking. All right, looks like we have another image. Oh, this is pretty interesting. I think that we can prompt it in this style because it did it pretty well, and then kind of compile our characters all together. So this is Milda, a 22-year-old character who is has red hair, of course, and as you can see, It's in the style of like a video game drawing, which I think is pretty cool. So I think I'm going to save this actually locally to my desktop and then add it into our repository. So we can kind of see all the images that we generate with this OpenAI model. So I'm just going to download that image and then we can work on generating some more images and kind of playing around with it, adding in some backstory as well. All right. I'm going to change the screen I'm sharing over to the GitHub code spaces. All right. I'm going to download that image. Then we can save it. And if you have any preference for which specific hair color or any other physical attributes of your characters you'd like to see when we're generating these with the OpenAI Dolly library, feel free to drop those in the chat so we can make this as interactive as possible. Then I'm going to be running, I think I'm just going to run the model locally, and I can go between that and the images just to make it a little bit easier. All right. So for our next character, they're going to be 28 and named here's the actual generator. What's going on here? Cannot reshape a sensor. Just running into all kinds of bugs today, aren't we? Oh, I see. So the input stuff I was messing around with earlier. It's coming from this. I'm not going to reshape this anymore. All right, okay. Let's see what's going on. I don't know what I did in the past 2 seconds to break our name generation model, but let's see. It's running quite a lot. I'm curious what. I'm going to stop this. Stop. I can. Okay. Restart the kernel. All right. I'm going to escape out of Copilot and see what error we're getting. Chart index is, oh, okay. Did I just not run all this in a while? PD, okay. Yeah, I just haven't run this in a little while because the kernel got restarted. Okay, so because when the kernel gets restarted on code spaces, you need to rerun all of the cells in Jupyter Notebooks. All right. Here we go. Models being trained. We're almost there. Okay, I'm gonna run the seed again. Okay, Millie is our name this time. 28-year-old Millie with black hair. All right. This is going to give me an error because I don't have the API key in. So I'm going to run this locally, and then I'll come back with a picture in just a second. All right. And then I'll be copying over the image I downloaded from our first AI generated character. Copying that in. Typically works. Okay. We'll copy those in after the fact. To not me. Sorry, I had technical issues. I missed a few minutes. Is it possible that I can get the source code? Yes, I'll be sharing the source code. It's on a GitHub repository that I'll be pushing to GitHub after the stream ends. Right now, I'm waiting for, okay, it looks like the OpenAI call just finished. So we have our next generated image. Okay, it's in a different style. So let's go to this real quick. This is the new generated picture. We have Millie. This one's, I think, like turns out also pretty well. We can download this one as well. It's a different artistic style, which I think is interesting. I like to see how the different artistic styles kind of compare between all of the different prompts. So we'll download those. I think we'll work through a few more of those, and we can also begin to add in a little bit more data to our original model for the part 1 of the stream. All right. So I'm going to move back to GitHub code spaces. All right. All right, let's make sure. Okay, this is all up to date. So this one, I'm going to have it generate another name for us. Here we have Mildy. I'm going to change it to something that doesn't start with MI. We'll do maybe X. Here we have Zanny. We do. Okay, let's do Zomi. And then Zomi is 23 and has just gonna say purple hair. Zomi is a knight who is fighting in the war between. I don't know what we can do. I feel like in the war between her home country of Songla and the evil I don't know, overlords in the neighboring Jaguar land. I don't know. It's kind of random, but we can use this to generate something that's like a little bit more, I guess, like expansive. Marcos wants to make her a Ronin, which is a word for a knight for hire. I think that's interesting. I'm going to use that one for, I think the next one, since I guess like generated a whole story, this one already, but we can do a knight for hire in our next prompt. So I'm going locally to change the prompt really quick, and then we'll have an image being returned in just a second. Oh no. Okay. The plus sign I'd try to do to make it easier to write on 2 lines did not work, but I'm fixing that right now. I'm gonna run it. It's thinking. Oh no, it looks like I accidentally unplugged my computer with my foot. So I'll be back in just a second. I'll plug that back in. I just realized my mic was muted. I think this one turned out to be pretty detailed, pretty cool. There's a lot of detail in the background with the countryside, the mountains, the war that's waging down at the bottom, as well as the war that's going on up here. Are like the night detailing as well as purple hair. I think it's like very detailed. It's pretty cool for how quickly it was generated. So I think that Zomi, this character, turned out to be pretty cool. And it looks like we have some messages in the chat for our next character we're generating. So I will generate a name for our new character and then make this their backstory. If any of you would like to add like additional context you'd like for new characters, feel free to drop that in the chat while I'm crafting up this real quick. So we're going to go back to our GitHub code spaces, and we can type up a few different character summaries really quick. All right, so here we're going to go up to our name generator, and we're going to, let's see, right here, we're going to generate our name. We'll use a different letter besides X. Let's use an M this time. And then we have, let's just men with an extra N. Mine, okay, Mavi sounds good. We'll do age 30. That's just like what I thought of off the top of my head. And Mavi is a knight for hire. Okay. 30 years old and has curly black hair. Mavi is a Ronin, a knight for hire, and is a dedicated but emotionally scarred individual. As is shown in her eyes and former physical wounds. All right, so let's copy this prompt. I'm going to put it into my desktop OpenAI prompt, and then we'll have a new prompt to go off of. All right, it's thinking. All right, it's done. Let's see what it came up this time. Oh, wow. This is really in-depth. I am impressed with what it came up with. It's like a whole like game player card. So here we see Mavi is dedicated but emotionally scarred, and the font is really cool. It reminds me of like the video game like on text conversations or like descriptors or dialogue that's going on. And it's also interesting to me that it goes between English and other characters that you're not able to fully read. I think the drawing is like super in depth as well. You can see I don't know if I want to say bullet or like knife wounds. They're just stitches with the bandages, but I think this is like very, very good for this one. All right, so I'm gonna move my screen back over to GitHub Code Spaces. I think that one turned out pretty well. And I'm going to upload the images into Code Spaces really quick. So we have a few more. If anyone wants to generate a few more images, feel free to drop those descriptions in the chat. But otherwise, we'll be moving on to maybe adding some more data into our existing model. And then I'll provide some resources to learn more about the models that I talked about and the one that we didn't quite get debugged during this stream. All right. So first order of business is I need to push the code. So stream series part 3. So I'm going to commit that so anyone who has the link to the bit.ly is able to see all the models we worked on throughout the entirety of the 3 series here. And I'm going to add those images in, and then I'll pull them up on GitHub Code Spaces really quick. All right. Okay, so I'm going to pull the repository down. All right, it looks like I have merge conflicts, so I am dealing with those off screen really quickly. All right, I think. All right, I think I'm merging. All right. And then I'm going to pull again. Here we go. Awesome. Okay. And then I'm going to copy in a few of those image files I generated so we can look at them side by side. All right, it's taking a little while. My apologies. All right. Okay, awesome. I'm gonna commit those. Added, open AI images. Let's sync those. All right, I think those went through. I'm gonna check really quick and see if I refresh the page. Those are showing up now. Oh, that's not what I need to have. I'm gonna remove that really quickly. We'll work through this. Okay, we're coming back to code spaces. All right, looks like it's there. I'm gonna pull down these changes. All right, and it looks like we have our images that we generated up here. So if you want to look at like all of them at once, we're able to do that now. So here we have Mavi. We also have, I'm forgetting her name, but we have the redheaded character. I think it was Milda or Millie or something. Here's Millie. This was Milda. The redhead was Milda. Here's Millie. And then here we have Zoni, who is our knight who's in like a war between different countries. I want to change their names really quickly here. So we're going to change this to Zoni. This will be Millie. Here we have Milda. And we have Mavi. All right. The only other thing I really think we will dive into today is integrating more of our national names data set into our name generation. So we'll just go up here, and I think I'm just going to start by integrating 2014 because I feel like the name trends will be like relatively opposite to 1880, which will provide a greater like name diversity, and I'll see how that changes our name generation model. So here in our data processing code file, I'm going to just add an elif statement, and we'll have elif row at index year is equal to 2014. I'm going to have it be appended to just names. So we'll have row at name, and then we will add this in. So this is adding into the list the count along with the name, and then otherwise it's going to break. So we'll have significantly larger portion. Okay, let's see. PD is not defined. That means we need to reload our import statements. I go down here. Looks like that ran properly. Everything's going good. Let's go down here. The model's running. Everything seems to be going good. All right, and then for the seed, I'm just going to do A and see what happens. And we'll do, for the range, we'll do like 7 since it has a lot more information. All right, Axelia. We have Amamula, Amarela. All right. Just going up with like a lot more complex names and a lot more like unique, I feel like video game esque names as well. And I think it's like probably because of the combination of the 2014 and 1880s data. So I think I'm also going to integrate a few data sets from the 1900s so we can have a little bit greater of name diversity. And then before we call it quits for the stream today, I'll be generating a few with the more complicated character names. So here, I'll do the same thing, but we'll do elif row, we'll do year equal to 1920. We'll also do, I think 1980. It's probably a good span. And then we can just add in this for both of them. All right, we'll run this. Seems to be going well. Rebuild the model. All right, all the epochs are running. Yes, as Marcos pointed out, the names are much more complex this time. I think because we're giving it more information as well as adding a length, we're getting a lot more interesting names and names I feel like you would like see in like Game of Thrones or something where they're a lot more unique than I feel like you hear in like your day-to-day life. All right, and then I will start this again. Instead of having an A, I think I'm going to go with a G, just so we have a little bit different names this time. Or actually, let's start with an A. We can see how it changes with adding in that it's 1990s before we mix it up with different letters. We'll run this. Okay. This one is not quite as unique because there's a lot of A's at the end. So let's see. Okay. These are, I guess, like honestly starting to remind me of those like, I don't know if you guys ever had these, but the like Instagram usernames where you just like I would like a lot of the same letter if someone had taken like your exact name. So it's interesting now that we have changed it. So I wonder if we change the temperature to a solid 1, how it'll behave. Okay, Anachi, pretty unique. Aldalea. Okay, I feel like we're back to what we were seeing earlier. I want to change it to a G and see the kind of names we're getting as well. All right. Interesting. All right. Yeah, I think we're back to kind of like a good area with our name generator. Yes, the name is stuttering with multiple letter repeats. And the temperature tended to alter it. So I'm going to go through and generate a few more images with these names. So I think that Gu Guntha is a good one to start. And I'm just going to say that Gu Guntha is, I don't know, a barista, but like in medieval times or something, and see what it comes up with. And Gugantha will have blue spiky hair. Gugantha is a medieval barista. All right, I'm gonna run this again. It's thinking. I'm always curious, like which specific prompts it finds to be complex, because you think it would be like the longer the text, the more complex it finds it, but that's not the case. I found that even like the shorter texts take like a while. It finds those to be complex. Oh my gosh, this one is interesting. This is very interesting. This is like very much like a video game character and not like a human. It looks like one of those like video game sprites. This is interesting. Yeah, I'm gonna download this one. But I think that I'll go and generate a few more and see like how it does. Okay. The next name is Guy Moria. And Guy Moria is going to be a witch with a penchant for mischief. Marco says maybe she's a changeling that returns to this form when she sleeps. That's an interesting possibility, and I guess it could add more lore to our video games, for sure. All right, I'm going to print out the OpenAI URL. Oh, wow. Okay, this one's more in like an anime style. This is Moira. Yeah, and then we have Moira, a witch with a penchant for mischief. It's in a completely different style, so that's interesting. Yeah, I'm going to, I think, generate maybe two more. And then I can show y'all where to access the code after the stream. All right. So, okay. Interesting. Okay, I think we need to change it from G. We're just going to do L now. It's doing the letter repeating thing again. Okay, now it did Lindsaya as a name. Okay, so generate a picture of a video game character named Lindsaya, who is a pilot who frequently loses her balance. All right. Okay, Marcos, in the meantime, I use Skybox to generate 3D worlds for free to help influence character generation. I'll have to check that out. Skybox, Blockade Labs. I'm spelling something wrong. It's not Blockade Labs.com. Yes, I am. Here we go. Okay, cool. Oh, this is cool. And you're able to prompt it specifically for 3D world generation. That's really cool. I'll show that before I show the image that OpenAI just generated. So this is what Marcos just shared in the chat. It's called Blockade Labs, and you're able to use it to, similar to the OpenAI DALL-E, you're able to query it for 3D game visualizations. I'm going to do beach with all the minions from Despicable Me. And then we'll do it in just realistic style. See what it comes up with. Oh, and it includes interiors of chambers. That's crazy. All right, is it gonna when it's doing this, does it mean it's generating, I'm assuming? Oh yeah, okay. Oh my gosh. This is so cool. I'm definitely gonna be checking this out later. And you even like down do the different things the minions are carrying on the beach. See that the faces are like slightly off, but it's really intricate for like how quickly it's done. It's really cool. And like the background with like the giant rocks and stuff. That's really cool. Oh, Marco says to look up. Oh, and you can see the sun as well. That's really crazy. And the clouds. That's a really cool tool. All right. I'm going to go look at what DALL-E generated for Lindsaya for our last character of the day. Okay, and here's our pilot. It looks like it's using like Lorem Ipsum text generator for this, but I'll share my screen. Here we go. Okay, so this is one of our OpenAI API generated images with the DALL-E library. So this is Lindsaya, a pilot who frequently loses her balance. It doesn't look like we gave it enough information to properly like type out a bio. It says like create an image and then like some like gibberish inside of like the overlay. But that's pretty interesting. Yeah, I'm going to download these and add them into the GitHub repository. That's all we have for today. If anyone has any questions on the models we built throughout the series, feel free to drop them in the chat, and I'll show you where to access the code after the fact. I have a few links as well, like where you can go check out some slides from sessions 1 and 2 in this series. All right, so let's go back to GitHub Copilot. So this is our code from the series. We have part 1, 2, and 3. We weren't able to fully implement the last part of the model, but we were able to build out our name generation pretty extensively. We have a lot more like unique name generators. We're generating some ages, as well as we use the OpenAI API to generate some cool characters. So, oh, I realized I'm not screen sharing. We have Mavi here, as well as Milda. We have Millie and Zoni, all of our characters, and I'll be adding in the other characters we did earlier. If you want to access the code here, I will send that link in chat again. It's just bit.ly/RNN code repo, and you're able to access everything in the Jupyter notebooks. And then I will be integrating the Kaggle data set, like the link to that if you want to check out any more about that, because it's a 1.8 line file. And we'll also have all the images in there, as well as like the context that we have provided for each of these. If you want to just follow along with the tutorial, you can just go through part 1, part 2, and part 3, along with the recordings after the fact. If you're curious to access the slides from either part of the earlier streams, I'll send those bit.ly links in the chat as well. So if you'd like to access the first repository, you can head to bit.ly GitHub repository for RNN1, and for the second part of the slides, you can just go to RNN2. Someone asked, are all parts needed for you to run the model? No, all parts are not. We built out kind of like the basic version of the model in part 1, and then built upon it in part 2 and 3. So you're able to run the code that we wrote in each session in those particular files. So as you can see here, in part 1, we didn't have the integrated larger data set. We just had like a simple list as I was walking you through like the basic model building. So you're able to run the more basic model in part 1 before you move over to part 2 and part 3. Okay, I'm gonna look up and see if we have any more questions. Looks like Wei was also impressed with the 3D Unity generator. I thought that was pretty cool. If that wasn't in reference to the characters, I thought the OpenAI generation was pretty cool as well. Doesn't look like we have any other questions. And then, oh, Wei is asking, how do you make the slides? They look so good. Thank you. I utilized a Canva template though, so I can't really take credit for the graphics on there. I just searched for different game templates, and then kind of adjusted the different images and the jumping characters on there to like make it a little bit more game themed. But I love kind of like adjusting the slides to be similar to the overall Global Hack Week theme. All right, I'll give you all another minute or two to drop any more questions you might have in the chat. But otherwise, I'll remind you to check in and register your attendance for this session. I sent the link earlier in chat, and it's also in the Discord, but I think most of you should have checked in already. Looks like someone's signing up for Canva, so love to hear it. I love using Canva. All right, it doesn't look like there's any other questions, so I'll be logging off from the last part of game world building with RNNs. If you want to access the code, I'll be pushing the final version just now, like after I get off stream, and you'll be able to access everything we did throughout this. If you'd like to run it in the browser, you can do so with GitHub Code Spaces, which is what I did, or you can run it locally as well. Thank you all for tuning in. I love getting to talk with you throughout Global Hack Week. And if you're tuning into any other Global Hack Week sessions, I hope you have a blast as well. See you all next time. Thanks.